So I thought I'd start and say welcome to everyone to this panel discussion on the case for retrofit. It's such an important issue that we're all facing at the moment, and that will become even more critical in the years to come. So I think we've set it up so you're all muted. But we'll later on we'll have a Q&A session. So if we need to, we can open it up for people to talk. We are recording this session, so if hopefully we'll be able to share it at a later date. And as I said, we'll have a Q&A session after the three presentations. I'll introduce each of the speakers in detail to start with, but what we'll do is the first presentation will be from Margaret Reynolds on retrofit, followed by a domestic retrofit case study from Alan Budden, and then Alex Reeve will discuss the challenges of non-domestic retrofit. So what I'll do is I'll introduce Margaret, and then she can start her presentation. So Margaret is an architect specialising in low energy. After years in practice, she completed a master's in environmental design at Cambridge in 1999. For the last 20 years, she has been promoting sustainable design with AC Architects from 2006, and then in her own practice. She's also very involved with a number of climate change activist groups in Cambridge and nationwide. And she also gave a presentation this lunchtime to the CFCI. So she is well and truly ready for talking today. I'll hand over to you now, Margaret.
Okay, thank you. I'm going to share my screen. Share. And go to this. Okay, hello everybody. I'm going to speak about the publicly available specification 2035 and why this matters, and also about the role of the retrofit coordinator that is defined in PAS 2035. Because I've been doing retrofits for decades, I've followed closely the development of PAS 2035. And I originally suggested doing this talk last summer to encourage more architects to become involved in retrofit. However, now that I'm doing a course with the Retrofit Academy, I've discovered that the role of retrofit coordinator, that is a major innovation of PAS 2035, was actually the idea of the RIBA in the first place. As Peter Rickaby, and I'll talk more about him later, as Peter Rickaby explains it, the intention was to enlarge the scope of work for us architects and to have us doing the kinds of work architects used to do in the past. Peter says, the retrofit coordinator role was invented by architects Bob Pruitt and Mark Elton, both pioneers of retrofit design that some of you may know, and they persuaded the RIBA to back it. So just to say, here we are, PAS 2035 is for homes. PAS 2030 has already existed for micro-generation certification scheme installers, that's MCS, installers of individual measures. And note that another standard, PAS 2038, is being developed for non-domestic, commercial, and institutional property. I've just found out that this is will be in consultation for a month from the 30th of September, so it will be available soon. Right, so why is the discussion of building retrofit standards so important? BEIS, the Department of Business, Energy and Industrial Strategy, and we'll be talking a lot about this department this evening, said that the UK is likely to fail to meet our carbon targets, our fourth carbon target. And failure to lower CO2 emissions from buildings to target levels is contributing substantially to this shortfall. In fact, lowering building emissions is the cost-effective pathway for meeting carbon budgets recommended by the Committee on Climate Change. So while there are many new initiatives in low carbon building design, we have to accept that new buildings make up only a tiny percentage of the total UK building stock. And consequently, new designs simply do not tackle this problem of emissions. And another BEIS quote, that's this department, to meet net zero, the building stock needs to be nearly completely decarbonized by 2050. So I originally wanted to make the point that architects' practices would benefit from meeting this past 2035 challenge. However, things are developing really quite rapidly. In the interest of job creation during a pandemic, and also lowering energy consumption, BEIS now has £2 billion of government funding, confirmed in August, for green homes grants up to the 31st of March 2021. It's the ECO team at BEIS which has expanded to take this on. That is, the ECO means Energy Company Obligation, and that's for occupants in fuel poverty. The ECO funding mechanism will be coupled with grants of up to £5,000, as we've probably all heard, for the able to pay. COVID-19 issues are really changing the landscape. Construction can actually be organized to observe social distancing. Householders who now work from home may very well want to reorganize and improve their property. And realistically, growing unemployment may bring new people on benefit to qualify for the ECO terms. And of course, all this is in the context of the UK hosting the United Nations COP26 climate talks in Glasgow, probably next November 2021. Okay, just a reminder that improved household energy efficiency is a win-win situation, both for individuals and for the country as a whole. So energy security for the country, comfort and lower bills, and well-being for householders. The arrival of Past 2035 is a result of relentless work over 35 years by Peter Rickaby, whom I quoted earlier, who's an architect and a graduate of Cambridge Department of Architecture. And some of you probably know him. Some information in my slides is from Peter, used with his permission. So what does Past 2035 actually say? I've taken some direct quotes from the text of Past 2035. The document runs to 194 pages, and there's a lot of detail, but I hope to extract a few useful parts from it. So just to clarify here, the term measures is often used. This refers to the whole range of energy improvements that can be made to a building. Each one is a measure. A major focuses of Past 2035 are risk, so that research on these retrofit measures shows that the best way to manage building retrofit projects is by identifying the level of risk each measure involves. Risk analysis has resulted in a new professional role, and that is the retrofit coordinator, which I mentioned earlier. This role is the main point of my talk. So I'm also going to touch on a few other things: professionalism, quality of work, and alternatives. Right, so this is and I'm sorry to say this is not a very good copy of it. I hope to get a much better one soon. The retrofit measures interaction matrix. So the measures are listed there. They're basically insulation, air tightness, replacement windows, doors, or roof lights, services, renewables, or efficient lighting and appliances. Each measure has its own quality standard and risk level, but crucially, it's the interaction of a number of measures that determines the highest risk level of the retrofit project. So if you look at the orange squares, those squares require complementary specification between those two measures, so that each specification must refer to the other. And the yellow squares require construction details of materials or measures that abut or overlap or interact. The red are measures that are not appropriate together, and the green are measures that are independent and they don't interact. So here's an example: ventilation. ventilation works carry a high risk. A separate ventilation risk assessment is completed by the retrofit coordinator before the whole project is assessed for risk. And it says, when installing any installation or air tightness measures or replacing windows in existing buildings, the adequacy of the existing ventilation shall be assessed and, if necessary, improved. That's really critical. Build right, build tight, ventilate right. Okay, so here's a Peter Rickaby slide, an old slide, defining the paths of retrofit. So you can see there, path A, B, and C used to be path 1, 2, and 3. So A is low risk, B is medium risk. Path A, low risk, requires past 2030 requirements of installation. Path B, medium risk, is more onerous. Path C, high risk, is more onerous again. And paths B and C, that is medium and high, require a qualified retrofit coordinator. That's where I should talk about this now. Okay. So retrofit coordinator looks at, and again, this is a lot of text, but I just want to say, in a recent Retrofit Works webinar at the end of July, the Trustmark head of compliance, Phil Mason, said that at that point, there were only 75 retrofit coordinators nationally who are ready to deliver past 2035. It looks like I might be number 76 when I complete my BAES-funded course at the Retrofit Academy, and Patrick will be number 77, or he may beat me to it. Okay, so looking at intended outcomes, the retrofit coordinator sits down with the clients and decides such things as energy use, energy costs, energy emissions, indoor air quality, condensation, overheat, try to pick up problems and priorities, and then if they want to achieve an energy rating or a performance standard. They might also look at deterioration in the house or flood risks, issues about heritage, and then, and this is where my work tends to be, other building works, which would be extensions, remodeling, and I'm sure that affects a lot of us. Okay, so to give you a quick idea of these risk paths, I'm going to skim through the kinds of matters they deal with. You'll see later that the retrofit coordinator is involved at managing risk at all stages of the project. So path A, low risk, you do a simple appraisal of heritage, architectural features, structure, construction and condition, and building services. You look at planning constraints, any defects, and any existing efficiency measures, energy efficiency measures. You could also do a SAP or RD SAP assessment, survey drawings, U-value calculations, and you might give a list of the services, building services. For B, now we're getting to medium risk, it's all of the above, plus you might be using passive house, just a second, back again, there we go. Passive house planning package. And you might be looking at site constraints and appraisal of occupancy. And B, the biggest thing, biggest change here is that you're doing a major assessment of ventilation. And for the things you might do on a path B would be annual fuel use, fuel costs, or CO2 emissions, and then more of an assessment of the traditional construction if that's present. And then for C, you go on to look much more detail or to consider air permeability, air tightness, protected building status of some kind listed or a conservation area, and the significance of that. And then you would have also involve a structural engineer's report. Okay, so for medium and high risk projects, that is paths B and C, the retrofit coordinator produces an improvement option evaluation, which is a selection, all the measures from which a selection will be made. This is followed by medium-term whole house retrofit plan, which gives the sequencing of these measures, including phasing over time. And I'm reliably informed, that there will be templates for these reports. The medium-term plan is lodged rather like an EPC or perhaps more like a Passive House Eurofit plan in the data warehouse. So the whole house plan is approved, but then each phase is approved later when it's complete. And householders will actually have access to this documentation through a property hub, and not all of it, but a good deal of it. So in the design stages, you know, the usual thing, but the retrofit coordinator ensures all these things. So statutory approvals, the health and safety plan, integrated fabric, that the approach is fabric first, that the specifications are compatible where they need to be and makes a coherent whole, construction details where required, and of course right the way through for new build, and that the retrofit design is clearly documented with drawings and specifications. And then on site, the retrofit coordinator goes through the contractor's program. The site staff are briefed, and this is toolbox talks that some firms are doing. Some are taking talks to site at 4 o'clock. And in one case, a BAES pilot run by the Green Register, the builders are being paid to listen to the toolbox talks, which I think is interesting and has not been replicated any other place as far as I know. Health and safety arrangements, weekly site visits, and in fact more frequently at the start when opening up. A review of any substitutions. Any substitution has to be to the retrofit coordinator's approval, and then arrangements for evaluation and monitoring. So the other things I was just going to say is that professionalism, the PAS 2035 is moving the industry away from deemed competence. So it's always been possible for a firm to be deemed competent, something like CIGA for cavity walls, gas safe for boilers, NIA for insulation, etc. So that they're moving away from, and because they want all the measures to be looked at as a whole. And an applicant deemed competent could acquire building regs through a building notice rather than full approval, which meant that these proposals were minimally checked by building regulations inspectors. And I want to note with emphasis that Grenfell Tower works were the subject of a building notice. In terms of quality, every aspect of retrofit must be subject to Trustmark quality control. And I think we all know the alternatives, which is what's pushing this whole system, which is not just Grenfell Tower. This is Peter Rickaby again. Glasgow, 4 tons of external wall insulation fell off the top of a tower. Edinburgh, the whole gable wall of EWI fell off on a school. In Preston, 300 homes are made uninhabitable by external wall insulation, and those people are still suing as a group, and it has not been settled. Grenfell Tower, 71 dead, on and on. And so we simply have to get this right. So just to sum up, retrofit's an important part of this national net zero strategy for 2050, and it's reckoned to be the cost-effective pathway. I mean, it's expensive, but that's what they reckon. PAS 2035 targets workmanship, coordination of multiple measures, and above all, the avoidance of risk. Building retrofit, all of this is now being propelled to the front by the COVID-19 and the economic situation. And the retrofit coordinator works by identifying risk from each measure and the combination of them, and looking at a whole house over time, even if it can't be done at once. And retrofit coordinator oversees medium and high risk projects from start to completion and beyond as the works are evaluated and monitored. Okay, so I will stop there and hand back to Patrick.
Great, thank you very much, Margaret. That was a really good summary of a very complicated and long document. I think, did you say it was 197 pages?
190, yes.
Yeah, so it's a really complicated a document, but it also represents quite an exciting opportunity. I did hear that to achieve our goals, we will need 30,000 of these retrofit coordinators, and as Margaret said, there's 75 at the moment. So as an industry, we need to gear up, and I honestly think that architects are in a really good place to fulfill that role. It's designed for us, really.
Yes, it's design that's needed.
Yeah, absolutely. Thank you very much, Margaret. That was really useful, really interesting. I'd like to turn to Alan Budden next. So Alan is an architect and a certified passive house designer. He is passionate about housing and the environment, and he established Eco Design Consultants 12 years ago to provide architectural services and environmental supports to other architects. And he'll talk about a case study. So I'll hand over to Alan now.
Thank you, Patrick. Okay. Okay. All right. Welcome. Today I was going to have a quick chat to you all regarding Coton. This is a retrofit project that we worked on the design stages. I'll show you some site stuff, but we weren't really involved with the site stuff. So you have to bear with me a little bit on that and some of the questions. It was designed around sort of the passive house principles. We'll go into a bit more detail in a second. Just to quickly introduce you, these are a selection of our projects from the practice. So Howe Park Passive House, which was the most airtight building in the UK till about a year ago, and now it's the second. Some passive house retrofits. This one didn't quite get to the NFIT standard because the airtightness on site, but was very close. We have I think the second passive house plus in the country, which was a new build house in the back garden, and the owners here are quite pleased because it means not only do they have a nice passive house, but no energy bills, not even for the electric car, the Tesla parked out the front. That's all powered by the house, so no bills, just an income. And then a full retrofit in London to a Victorian terrace. Very good. So today I was going to talk to you about this house in Coton, which is open as part of the open house for Eco Open Houses in Cambridge. So you can go and visit this one. But who's a particle physicist, so really small little bits of physics as compared to the buildings and stuff we're doing here. So he was very, very passionate about the numbers and the science behind it all. His biggest challenge was basically he has this fairly small 3-bedroom house and wanted more space. He also had quite a limited budget, and he was also quite interested in the carbon and environmental aspects, including some of the carbon payback. So we basically use the passive house principles. I'll go quite quickly through this because it's not about passive house today. But generally, this is kind of a slide on passive house. So if you take a new build house, building regulations is around about 85 kilowatts per square meter. It changes because the shape and building regs doesn't take shape into account. So if you then do super insulation, so U value is less than 0.15, probably in reality in the UK around this sort of area, it's probably nearer to 0.011, to be honest. You then make sure you've got an efficient shape, and you can bring it down even further. Add triple glazing, again, all helps. Airtightness is a huge bit. You can see it jumps down quite a lot with that. So an airtightness of 0.6 can make a huge difference, and that's one of the major things I think is really important in terms of the refurbs and making it, like Margaret said earlier, build tight, ventilate right. And if you do that, obviously you then need an efficient ventilation system, and the ventilation again helps a little bit more. Make sure all the detailing is correct in terms of thermal bridges. And basically what you get from that is high levels of comfort. The surface temperatures are all very equal, and you have minimal heating requirements. And that's basically how you get to passive house in very simple terms. Just looking at all the details and going through it. Okay. Just a quick one here. This is some work done by Leeds Metropolitan University, but there's also been some more recent stuff done by Oxford Brookes University on a slightly bigger sample size, taking buildings that have been designed to be low energy and looking at how they actually did measure in the end. So the blue lines here are the predicted, so the SAP calculations and other things, and the red is the measured. As you can see, the some which are quite shockingly different. So this one's over 100% difference. The interesting bit is these ones down here, which to start off with had very low predicted energies, but the actual measured was also very low. And this is very similar findings that the Oxford Brookes are finding as well, that the passive house seems, and the methodology seems to work in terms of actual reliability in what you're getting. It's a real Dieselgate, I think, waiting to happen with these differences in SAP and EPCs. So going back to that project, what we did basically, we took the passive house principles and we used the PHBP to model the house, and we then did various. We basically pimped the PHBP a bit to produce some nice graphs and other bits and pieces. So basically, we look at each of the elements in turn. We kind of look at how if you increase the insulation thickness, so each of these coloured lines is a different insulation type, and this is the thickness, and this is how much the overall energy use goes down as a whole. And basically, the external walls, with external wall insulation, we get about 9%. The air tightness and ventilation was a really big gain area for this house. Getting the air tightness down itself, we assumed an air tightness of 10. We didn't actually measure it because there wasn't really the money to check it. Could well be worse than 10. That gave a 32% improvement, getting it down to sort of passive house standards of 0.6. And if you then put MVHR on top, you're getting down another 20%. Is it 20? Yeah, about 20%, down to 53%. So you can see that's a huge measure and one of those really quick, not necessarily quick win, but a really important win. Also in terms of health and other benefits. Basically, then what we do is we've done all the different measures. There's a lot more than this. We then combine it together into various stages. So if you did these list of things, you could get to the ENERFIT standard, and that's an 88% improvement on the existing house. So that's kind of the analysis that we did, and we went through and we kind of selected the path going forward. Quickly sort of looking into phasing projects. If you decided that you've got, like, I think he had about £30,000 he wanted to spend. I think he may have spent a little bit more than that in the end, but he could have just spent that on a little bit of work everywhere, and so which would be a shallow retrofit. And obviously that was step one. That would just lock you in terms of where you're going to get to in terms of your performance. Because if you do external wall insulation, you're not going to rip off the render and then come back later and put some more insulation on and re-render it. It just doesn't make sense. So if you look alternatively at a deep retrofit, you may decide to do different elements. So you may do just the extension, which is kind of what we were suggesting to start with, and do it well. And then later on, maybe do the external wall insulation, and then maybe the MVHR, and slowly work your way around the house. It may take you a lot longer, but what it does mean is that you're not locking yourself in. You can keep going until you get to a very good end result. I think another analogy I heard recently was if you have a fruit tree, you can take all the low fruit at the bottom off the tree. And if you did that in your orchard, you're not going to go back and then take off the top stuff later. It wouldn't be financially viable. You want to do it all in one go if you can, or do one tree at a time. This is what I think Margaret referred to earlier. It's called EuroFit. So that's ENERFIT by phases, which quite good is that you can actually get certificates and lodge partial completion, so that if you did end up moving or whatever happens in life, you can then sell the property with that certificate, and the next homeowner has got some reassurance that it has been looked at and it is okay in that sort of partial state, and it also has a plan for them to take over to carry on when they have time. Another interesting bit we've been looking at more recently is the embodied carbon. I know that's probably going to be another talk that Patrick's organising, possibly. So what we did here, this is a different project, to be honest. What we've looked at is a number of different insulation types. So going from the black one, which is wood fibre, which is hiding underneath the red one here, you probably can't see it. Rock wool, polystyrene, Kingspan PIR K5, and basically, as we've taken it as 25mm strips. So as you go from, say, 100mm to 125mm, that extra 25mm of insulation will have an embodied carbon. And what we looked at here is what the saving is in fuel for that extra 25mm. So, and then looking at the payback period in carbon terms of that element. So what you can see is things like the Kingspan K5. If we go from 275mm to 300mm, we have a payback period of about 175 years, which obviously in environmental terms is a complete no-no. We shouldn't be doing that. We need to be limited to about 10 years. Recently, we've had a passive house with a C shape that the client wants to get to full passive house, and we kept saying that it's probably too far, it's probably too far. But I like a challenge, so we did the PHEP, and we looked at it, and in the end, we were getting up to about 300 mil of Kingspan. That was the only way it would work.
Yeah.
And we basically then said to him, look, we don't think this is sustainable. We need to rein this back, because the embodied carbon is such a huge amount. You're probably doing more damage to the environment than you're saving. So bring it back. So we did. And so we ended up, I think, going for the ACV standard instead. So it's a much more sensible way. So on that project, these were kind of the thicknesses that we would need for the maximum thickness in terms of the 10-year payback. And so these were the Enefit figures. So they're all underneath it. So it was all achievable on this other project. Okay, so quickly going on to the Cooten project. Basically, this was the existing house. It had a small sort of kitchen diner space at the rear. And basically they need more space. So a simple extension to the rear was kind of designed so that in a second phase, the external wall insulation could be added. And then potentially internal wall insulation at the front and a few other things at a later stage. And that's the section. So again, we used very traditional materials. It was masonry, just because that's kind of an easy, affordable solution for most small builders. This is a picture of the external walls just going into the foundations. You can see quite a thick cavity, and so there's a more detailed picture of the cavity wall. You can see XPS insulation below the DPC and Drytherm 32 above, with the Teplo wall ties. So I think that's a 200 mil cavity. And you can see here, this is the first phase. So you can see the mineral wall starting to poke out here. This was so that we made sure, and the blockwork doesn't join up. This is to reduce the cold bridge in phase 2, so that the insulation can be continuous and that can join up with the insulation on the external walls. Luckily, I'm not sure whether he got more funding or whether he got a good rate for the build. He managed to do the external wall insulation in the first phase. So this is the external wall insulation going on. And the existing windows, so again, the insulation is going in and wrapping onto the frame as much as he could on the existing double glazed windows. The extension nearing completion there. You can see the new windows, new triple glazed windows to the rear extension. The cladding going on, and the weatherproofing membranes on the outside. Again, another important thing. It's not, which we kind of stress, is it's not just about the air tightness layer on the inside. It's also about a good weather tight membrane on the outside. So all these membranes are hopefully going to be taped. This is the MVHR unit that was installed within the loft of the existing house. He then also looked like he's gone ahead and done some installation up there. I would point out, though, you do need to be really careful about the amount of internal insulation you do compared to the insulation between. We didn't get involved with this bit, to be honest. I think it may be a little bit too much on the inside. You can see that the pull unit here and all the ducts going out. Interesting, this is what he did. So it's going from the loft space above the existing house, going down through the existing house to go out into the extension. Interesting, you can see what he's done here is his thoughts about the phasing and the fact that at some point he wants to insulate the sloping roof. So he's taken out the plasterboard, made sure the air tightness layers go in, put in the insulation behind the ductwork so you can then build up to that later. So you can see he's thinking about doing those stages when you can. And that's really important if you're trying to do these things in stages. And you can see the MVHR ducts being rigid, which are really good, and the silencers and so forth being put in, which is important to get these things designed well. Some more of the air tightness tapes and detailing going around the existing building and bringing the air tightness layer onto the blockwork. This shows you the rear sill where the patio door is going to go on, and this is a piece of compact foam. Basically, the doors and windows want to be positioned within the insulation zone to reduce the form factor, the thermal envelope, and also to make it as efficient as possible. So this is being held in place before the concrete is poured. This is basically compact foam is a rigid polystyrene that has kind of the structural properties of timber, but it won't rot, and it's better thermally than the timber. So you can use it in sort of places like this to provide some structural insulation. That's the floor insulation going in. I'm assuming he had some Certex left over, so he thought he'd up the performance in this piece. And there's Bart in the finished property, which I believe is open for you to go and have a look at, and I'm sure he'll be very enthusiastic to show you around. Just one kind of final slide. This is an energy slide that he sent through in terms of what he's measured in terms of his gas and electricity bills. The blue ones here are the gas, which obviously is heating and a little bit of cooking, I believe. So he started off here with, I think that's around about 870 kilowatts. 8,000 kilowatts per year, and now he's down at sort of 1,900 kilowatts per square meter per year. Right, units. I had a quick look to see what it would be if he went to the Passive House Enefit at 25 kilowatts on the size of the property, and that's where it would be. So he's actually pretty much achieving the Enefit standard in reality, even though he's still got double glazed windows and he hasn't finished off all the retrofit. But we don't know quite what the temperature he's heating the house to, so there might be other extra usages, but you can see huge benefits. And I know anecdotally he was saying how even just doing the extension, the rest of the house felt warmer, which is really quite interesting. These are some other projects we're working on at the moment. So this one's just started on site in Oakington to North Cambridgeshire, just in demolition. We've got another one we're just finishing working drawings for in Cambridge as well, and a couple in Oxford and Abingdon. Interestingly, these two are both going to full Passive House standard with internal wall insulation. We had to check the PHPP several times to make sure that we hadn't made any mistakes, because it didn't seem that it was possible. But they're great form factors because they're mid terraces, and so that they're not losing heat to the neighbours. Okay, thank you very much.
That's great. Thank you very much, Alan. That's I think it's really interesting to see the kind of continued message of the benefits of planning forwards and thinking about what you'll do at the next stage, and not locking in those the benefits. If you retrofit to a shallow standard, you're not going to do any more. So thinking about that long term and achieving that goal is really important. So yeah, so it's great to see, and it's great to see photos of a self builder that's really passionate about it and wants to do it. I think he's a brilliant client, I guess.
Yes, very lucky in that respect.
It's maybe something that we'll touch on later on, but I think certainly the costs is something that is really interesting, and then comparing the embodied carbon, I think that's something that we need to think more about on designing buildings. And that graph, I think, is really powerful to say that you can insulate to 250, 300 mil of insulation, but if it's not climate sensible, then why would you? It would be better to do less or design better. To take that design and make it more efficient. It's kind of the powerful message of and the tools that we have available that we can use. And you've made Passive House sound so simple. It's not, but it is achievable. I think, and airtightness. Yeah, absolutely. It is achievable. Okay, so I think we'll move on to our next speaker. So Alex Reeve is an architect who has been based in Cambridge for the past 20 years. An interdisciplinary master's in environmental design and engineering he completed some years ago at the Bartlett has given him a particular interest in integrating architecture more closely with building services, engineering, and building physics. For the last 3 years, Alex has been working as an advisor on sustainable construction at the University of Cambridge's Estates Division. He has asked me to make it clear that any views that he shares are his own and not rather than the university's. So I think that is clear, and we value it very much, Alex. Thank you very much.
Great, thank you. Hopefully you can see my presentation.
Perfect. Yes, Alex.
Good. Yes, so to complement what Margaret and Alan have been talking about, I was going to focus a bit on the technology and the cost side, and perhaps more of a non-domestic slant to things as well. First slide, another graph. So this is trying to illustrate how gas is becoming the major issue for us to deal with. So the blue line is represents the carbon emissions from electricity for a typical office, and the figures I'm using here, 120 kilowatt hours per square metre for heat, from the benchmarks that are used for energy performance certificates. And so 95 for electricity, but because the grid is decarbonising, almost can sit on your hands. I'm not advocating that, but you know, the grid is decarbonising for you. Whereas gas, here, the gas grid is not decarbonising. Gas is gas. We could say that maybe in future there'll be some injection of hydrogen, maybe more biomass, carbon capture and storage. All things are huge. All these things are hugely expensive. I think, to echo what Margaret was saying, retrofit is what BASE are saying is the most cost-effective solution. And the projections for gas carbon intensity are for it to stay the same. So as a client, when you sort of sum the two together, you reach a point at which you just can't decarbonise your building any further unless you actively go ahead and remove the gas-fired heating and move to an alternative. So what alternatives are there? So this is a very tempting alternative, direct electric panel radiator. It's very neat, very simple, low capital cost. But of course, there are problems with doing that. I mean, the first one really is that we should all know that electricity is a lot more expensive per kilowatt hour than gas, more than 4 times. So we would be exposing our clients to a very high operational cost. There are also issues with availability of that electricity. There just simply isn't enough renewable energy in the country to meet demand if we all moved across to direct electric. And you could actually obviously buy the electricity at night, store it in a battery and then use it during the day, or in a heat store, but you no longer got a simple, cheap solution. So this graph, I think, is very powerful. It's something that the UK Green Building Council have been using, so you can go to the link below. So this is where we are at the moment with our renewable energy capacity. And in the pipeline, we've got plenty of renewable energy capacity sort of coming down the line, more wind farms, interconnector with Norwegian hydropower, interconnected with more French nuclear electricity, Hinkley Point and all that kind of thing. So by 2050, we should have certainly more than doubled our renewable electricity generation capacity. However, if we converted all our energy demands today into electricity, so that means our vehicles, imagine them all running using electricity, and our space heating, imagine it all running using heat pumps, that's how much electricity we would need. So there's a bit of a gap. So again, the message is retrofit first, because we've got to close this gap. So we need to move away from gas towards electricity, but we need to use it really efficiently, having done our fabric to the best of our abilities. So hopefully we're all familiar now with heat pumps as architects. So you have a refrigerant cycle, you take the heat from a source, so either the air or the ground, and you upgrade it using compression and expansion for use for space heating and for hot water potentially. And you can, of course, reverse it for cooling as well. So easy solution again, we just stick lots of evaporator units on the side of our buildings, and hey presto, we can deliver our heat without the use of without using gas. I've deliberately used this photograph. I'm afraid it's one of the more shameful parts of the university estate, but it shows that clearly there are aesthetic issues with this approach. Also, noise is a very significant issue, and also something that we as architects, I think, need to talk to services engineers about in a more educated way is the length of the pipework. How long, how remote is your heating system from your heat source? Because of course you have heat losses with the pipework, but also it's using a refrigerant in the cycle, and refrigerants have at the moment a very high global warming potential. So there is some move in industry to try and limit this, but sort of domestic size systems are now beginning to use this refrigerant called R32, but that's still, for every molecule of that, is 675 times the global warming potential of an equivalent molecule of carbon dioxide. And a lot of systems are still using this, and the bigger ones, R410A, which is more than 2,000 times. And although you should be using registered engineers for any work on these systems, leakage will occur, particularly if there's a servicing issue or you need to remove the system at the end of life. You should assume probably about 10% of it will escape. So the more volume of this refrigerant you've got in the system, the more is likely to escape. So that's where the distance matters. And also you need to be a little bit wary of variable refrigerant flow. When you sort of talk to engineers, you might hear them say the letters VRF, this is a great solution. And, you know, it might be the right one in certain circumstances, but we need to be cautious because the volumes will be that much high. It's a system where you're distributing the refrigerant around the building rather than using hot water to distribute your heat around the building. So that's a conversation that needs to be had. And also these are going to be banned in the medium term because we're there's Kigali Protocol, and alternatives at the moment to these are can be very low global warming potential, not much on the market yet, but they tend to be highly flammable. So propane is a sort of an easy swap out, but as we all know, there's a fire risk with that, which would be difficult to manage sort of inside a building. So the other thing that we need to be comfortable talking to services engineers as a profession is the concept of delta T. So the temperature difference between your heat source, so the air and ground that you might be sourcing the heat using your heat pump from, and the temperature of your heat emitter inside the building. So in the context of retrofit, typically we're going to be dealing with traditional radiators. They might be operating at a surface temperature of say 70 degrees to keep the space warm. Unfortunately, the bigger the delta T, the bigger that temperature difference, the poorer your heat pump will perform. So new build, it's fairly straightforward. It might be freezing outside, but you might well have an underfloor heating system for new build. And, you know, it could be in this zone, very gentle temperature. The uplift is very modest, could be less than 30 degrees. So you get a very high coefficient of performance. You probably get more than 4 times the heat out of the system as for the equivalent kilowatt hours of electricity you're putting in. But it drops very rapidly. So that 70-degree radiator, well, it's off the chart. There just isn't products available to deliver that. So that comes back to looking at the fabric. We need to improve building fabric with wall insulation, windows, ventilation, heat recovery, and so on, so that you can bring back the emitter temperatures to sort of somewhere in this zone, the sort of 45, 50 degree zone ideally. And then you can get efficiencies that are above this sort of magic threshold of 2.5, which is the threshold that's historically been used to define whether a heat pump system is sort of truly renewable and worthwhile doing. And so that's where this important interaction between architectural decisions and fabric and decisions with building services matter, and also cost. You know, are you going to try and keep the existing radiators, or are you going to have to rip them out and put in twice the number so that you can operate at them at this temperature and still meet, cope with the heat loss that's inherent in the building. So then the other conversation we need to be having with engineers is, where does the heat come from? So typically it's a choice between air or ground. Water is sometimes an option, but not often that you have a water body very conveniently available. So air source has the advantage that you need much less sort of plan area typically compared to ground. So ground, if you're using it for heat only, you're obviously extracting the heat and you're gradually cooling the ground down if you're not careful, and you start to lose the efficiency. So you need an awful lot of volume of ground so that it can replenish itself slowly during the summer. And so in Cambridge, typically with projects I've been involved in, boreholes are being drilled up to 200 meters deep before you hit the bedrock. So, you know, you've got plenty of volume you can get. But you still might need, for a megawatt of heating capacity, you might need this sort of area, 5,000 square meters of surface area. If you're in a rural area where you can just have shallow coils, then it's a different story, but again, is a rare opportunity. Whereas for air source, you might only need, for the same megawatt of capacity, you might only need 200 square meters of roof. So a very important consideration. But ground is more efficient, because ground in winter it might be at 12 degrees typically, whereas air might well be below freezing. So there's an efficiency penalty. So actually sometimes the ideal will be to have a mix of the two. And then another option that I think we'll hear a lot more about is a heat network. So having a loop that runs round, you keep it this loop of hot water at a particular temperature, might be 10, might be 20 degrees. You sort of input it where you can from waste heat sources or air source heat pumps or ground source boreholes. Run it around, and then at the individual building, you might then upgrade that heat the next step to your whatever emitter temperature it will be, and as sort of suits the particular buildings. So the trouble is, of course, this is a very high infrastructure cost, but there is some government support for this at the moment. So I'd urge people to look at what's happening at Swaffham Prior, planning applications in at the moment for a heat network there. And certainly it's something that the university is going to be exploring. So to return to that graph that we started off with, where we were stubbornly stuck and couldn't decarbonise by 2050 unless we moved away from gas, I think a typical scenario will be you cut your heat demand through fabric measures. Maybe you cut it by half. In Passive House, you certainly cut it by rather more than half. And then you have to meet the shortfall with heat pumps. And by cutting it that much, at least you've got a fighting chance of achieving good efficiencies. So a few thoughts about cost. It's something, again, we as a profession are going to have to get much more comfortable, I think, talking about the options with our clients. So capital cost, there's no getting away from the fact that fabric measures, swapping out from gas boilers to heat pumps is going to be a high capital cost. So we've got to talk about life cycle cost. There's also going to be this payoff between how far you can go with fabric costs and then meet the remaining decarbonisation target with building services. So you go as far as you can, but there are limits, particularly with more sort of heritage type buildings, particularly if you're going to need to deal with problematic moisture control in walls. So it's finding that optimal balance, and every project will be different, particularly with retrofit. So running through a few scenarios is going to be necessary. And electrical capacity costs, that's something that often will be overlooked. I'm not sure even cost managers are quite grasping this yet, as if we need to meet our heat from electricity, even with heat pumps, rather than gas, it's a big addition to the local grid. And it's very likely that a lot of projects are going to come along, go a certain way down the line, and the local power network is going to turn around and say, sorry, the substation can't cope. So pay us to upgrade the substation or build a new one. So certainly looked at a substation of 500 kilowatt sort of capacity is in the region of £200,000 of cost. And so that can just kill a project. So again, that might favour a revisit, look at fabric first and save substation upgrade costs. There will also be ongoing costs that are going to climb inexorably in terms of taking electricity at times of peak demand. Certainly commercial plants are going to be seeing those prices, and the rollout of smart metering will start to affect domestic plants as well, I'm sure. So that's something that needs to be talked about in that life cycle context. And also, all energy costs are completely dwarfed by staffing costs. It's a truism, but anything that is about improving fabric will improve comfort, and even very modest improvements in staff retention and productivity can start to pay for it. So it's important to sort of have that in the conversation as well. And then another one to be very aware of is stranded assets. If we don't do something now, when you've got an opportunity to insulate a wall and so on, then grab that opportunity, because actually you may well regret it, very likely to regret it further down the line, particularly as energy performance certificates are going to be tightened. There was a recent BEIS consultation about what the threshold should be for someone to be able to either let or sell their property. At the moment it's a very modest E, but the recommendation in the consultation was to reach B by 2030, which is only 10 years away. So people with poorly performing buildings are going to start to regret it pretty soon. So anyway, that's the conclusion of my thoughts. So I'll hand back to Patrick.
Brilliant. Thank you very much, Alex. That's really, really interesting summary of non-domestic and the challenges that you're facing, and the solutions. The Swaffham Prior heat district heat network is really exciting, and it's likely to be one of a number of solutions that we have to do. I noticed in the National Grid's recent report, it said that no scenario up to 2050 doesn't include upgrading the thermal envelopes of our existing buildings. So it's imperative that we have to do it. It's on the cards. We've had some really interesting questions with a bit of a theme. I'll let Alex have a bit of a breather, but I wondered if I could ask Margaret to respond to the themes of dealing with listed buildings, and maybe your view on that. I know you've recently done a talk about the church. I don't know if that's something that you could.
Yes. Listed, the church is not listed.
Okay.
So we were relatively free to do what seemed best economically there, and we changed it a great deal. For listed buildings, you've got a whole different situation. You can't use external wall insulation. I mean, it's the appearance that's listed, unless it happens to be rendered. And then, I mean, I think Trinity managed to do one, but it took about, they've been monitoring it for 7 years. I mean, it is a huge undertaking. So you're with internal, you're not really going to be able to get the same standard, because you've got to use hygroscopic, which is moisture absorbing, responsive material to allow the old materials to dry out. So I've built an extension to a listed building, but I have not actually dealt with it. That is really quite a specialist thing. John Preston knows a lot about that. And the Traditional Building Alliance has a lot of advice on that, but it is a major undertaking.
Absolutely.
I think Judith also asked about conservation officers.
Yeah.
And again, this is interesting. I'm doing another webinar on Saturday on a house that I've recently finished retrofitting in a conservation area. And we didn't think we had a hope of rising above the existing ridge. I mean, it's absolutely forbidden, and this was a very low ridge. So we thought, and all of the precedent was, can't do it, haven't let this person do it, etc. And when we came to it, we did a very careful study of all the houses and what they'd been allowed to do. And then we said, if we make a small rise behind the ridge that is not visible from the road, these people can get reasonable headroom and a third bedroom. Otherwise, they will move and they will be driving, and we got it. I mean, that's what was astonishing. If you do your homework and you say, but the National Planning Framework says we should be looking at sustainable value and not necessarily just at conservation, you can make a case. You must really do your homework, and planners don't have much time to do that. But if you lay it out, as I say, we were lucky, we got permission. So that's a conservation area. Listed buildings, again, that's pretty specialist stuff, and you don't really dare tinker with the fabric much.
I guess that's it kind of reinforces the argument that we should do as much as we can where we can.
Yeah.
So on the existing buildings that aren't listed, we need to be making them even more insulated to allow for the fact that there will be properties that won't be able to. And we don't want to lose the heritage buildings that we have. We don't want to lose those cultural elements. So it's key to do as much as we can. And as
if you think of the range of measures, you might be able to go to the floor or the roof, and that would, it depends completely on the design, but you can look at the whole range and see if there's some places you can push it. It's a bit like passive house planning package, where you can load up certain bits and averages out.
Alan, have you got any thoughts on conservation areas?
Yeah, I would agree with Margaret. I think there are a number of ways you can do stuff. I mean, to be honest, we're just starting to look at one at the moment in Chelsea, a listed building. I don't think we're not going to get to passive house, I'm sure. But there are elements that already there's problems with damp and stuff around the chimney at the bottom. And I'm sure by introducing ventilation systems, we're going to help that. So there are things we can do that will help the building last for longer, as well as improve it. So I think we are looking at sort of diathanite, which is a cork lime plaster on the inside, maybe with some wood fibre. So it's all moisture open. It's all the right sort of stuff you need to be really careful at.
That's interesting.
And looking at the windows and stuff, that maybe secondary glazing, depends how far we can convince the conservation officer. I think, his pre-app came back and said we can't do triple glazing, because I think his exception is that we're going to have thick, chunky frames.
Yeah, but it's not necessarily true.
No, because if you've got sliding sashes and stuff, you've got a sash box behind it, you can hide some of that frame.
GBS, Green Building Store does, yeah.
The
other thing that's interesting, I know a company in London who did a listed building where they couldn't do the outside and they could barely do the inside, but they made it very, very airtight, and they got the energy use way down.
Yes, that's
without much, distorting insulation.
Yeah, and also that's protecting the fabric, which I think is really important. Yeah, the airtightness, it's stopping that moisture getting into place it shouldn't do. So just by looking at it properly, you can really move it forward. So I think there are opportunities, but you just need to be really sensitive and really careful. I think that's the main thing to learn.
Yeah, Alex, do you have anything to add? Is there?
Yeah, to sort of echo that conversation, really. The university's been looking at a sort of 1930s building and in a conservation area to try and achieve the NFIT standard if we possibly can. Not yet, the financing isn't quite yet there, but we're keeping our fingers crossed. But we went in for planning, and on the basis of replacing the windows with triple glazing to achieve the thermal continuity, but also the tightness. And the conservation officer wasn't entirely keen, and it's a very difficult balancing act to draw. But the architects there, what they did was design the reveals in an elegant way to avoid that sort of chunky feel. And the committee were convinced. They've given permission for it. But again, to echo what Margaret was saying, you have to have your facts and figures. They backed it up with a lot of analysis using Passive House Planning package, showing the difference between the various choices that were available. So yeah. And then I think on the subject of sort of listed buildings, we're looking at our new museum site at the university, which has got a mix of listed buildings and is in a conservation area for the non-listed buildings. And there, I think, yes, it's going to be really tough to improve the fabric very significantly, not just because of the listed status, just because they're so ornate. You know, there's so many sort of intricacies to them that just to get the thermal continuity would be pretty challenging, and so the costs just rack up. So this is where it'll be a blend of do what we can with the less significant buildings and look at a heat network, because again, we can't just stick air source heat pumps on the side of these listed buildings either. So we've got to put the heat pumps, well, it's probably going to have to be quite a lot of boreholes, but then heat pumps on roofs, or actually carved out of buildings that are of less significance, where you can adapt them in a sensitive way, and then supply the heat from there to the listed buildings. So yeah, it's a real challenge.
Oh, go on, Margaret.
Just one other point, which is that if you have to resort to internal insulation, you do lose that huge benefit of the thermal mass of the old walls. So you may not have overheating problems, but there are people with several story buildings where at the top, they've put internal insulation and they are very hot in the summer. That I don't know what you do with a listed building unless you could get some kind of added thermal mass somehow upstairs. Anyway, I mean, that's just a thing to point out.
Just to say to that, Margaret, some of the installations you'd be looking to use, like the wood fibre and the lime plaster type things, do have a higher thermal density.
Yeah.
So they're better than if you start looking at, dare I say, the Kingspans and the Certex and stuff, in terms of that thermal mass.
Yeah.
No, it's a really good point though to think about the overheating. It's it will be a tricky issue to deal with. Okay.
But your triple glazing will help in reducing your thermal gains, so that does show to help.
And external shading if you can manage it.
Yeah.
And I guess this is where the modelling, the PHPP tools that we do have or others can help with that. But I guess the message is do your homework, certainly from the conservation or the listed building side of things. I think if we move on, we've got a question from Arjun, who has asked, how do you think retrofit can be made more accessible to lower income and more vulnerable members of society who will arguably benefit most from lower heating bills and improved air quality? It's a great question, and it's a critical one. Alan, do you want to give it a go?
Yeah, it's a difficult one, because to be honest, the retrofit does cost money, and it annoys me a little bit. Sometimes you hear the government talking, oh, we can retrofit every house for £20,000, and I just don't think you can. I think it needs to be more than that. And so, I mean, things like the Green Homes Deal grants and stuff, again, it's scratching the surface. But I think there are, I mean, air tightness, I think, is one of those areas that I think if you can get that, then that is fairly cost effective if you can do it while you're doing other things. And there's some great things that Energy Sprong and other people are doing in terms of coming along and having almost prefabricated kits that just fit on the outside of your house. You're still talking more than the 20, 30,000, but what's quite interesting is some of the things that they're talking about in terms of retrofitting an area. So you might have a quite poor area that you want to retrofit the houses. The values of those houses are going up because of it. And so the social benefit is also there as well. So urban design wise, it's sort of making those places better. It's also reducing down sort of reliance on the NHS and other help.
Yes.
So if you start looking at it as a society-wide thing, they reckon that actually the money spent on that is actually paying for itself without the fuel bills and everything else, just through kind of the social improvements and the other improvements. So if you kind of look at the finances in a different way, it kind of works to do that, but it does mean all the joined up thinking, the stuff that Alexander was talking about earlier about getting your HR department to speak to the finance department, to talk to the maintenance department, to get those costings to work. It's kind of what's needed as a society benefit.
Yeah.
My thought.
And to get costs down, I think collective solutions obviously are going to be more cost effective, economies of scale. And so I've had a leaflet through my door about, do you want to join a collective to put PV on the roof, which I think the county council have been promoting. But you could imagine the same sort of approach when it comes to retrofit. So if you've got a row of houses where a kind of solution could apply to the whole lot, then you can try and recruit people. And I suppose going back to the Swaffham Prior heat network, there, I mean, there's benefit to it's sort of obviously open to anyone in the village, and there are council tenants as well, and so the benefit there is more straightforward because people have to use oil to heat their homes, which is really expensive. Maybe not so much at the moment, but normally it is. And there, I suppose the financing is very long term. It's an infrastructure approach to financing. So actually the payback is through selling the heat over many, many years with protection to the users in terms of having a kind of a sort of control over the legal control of some kind. Don't ask me all the details, but it's certainly worth looking at that website. So
there is hope that by making retrofit measures more carefully analyzed and more subject to these risk controls, that the banks will respond and be happier to lend. As far as I know, Ecological Building Society is the only one, and I think it's only existing customers, but they do, the idea exists of banks giving loans. The lower you're aiming, the more they'll lend you. And the ECO program is designed for people, strictly speaking, in fuel poverty, which means that you're paying more than 10% of your income. And I don't know the ECO program is going to continue indefinitely. I think it's going to be replaced by something else. But there is funding for that. And if you're on benefit and you go for the, anybody in your house is on benefit and you go for the Green Homes grants, you can have 10,000. You don't have to match it. So that's something. Making retrofit cheaper, it is very expensive to do the laborious work to take an existing system and tweak and turn it around so it behaves differently, and that's why you have to keep monitoring it and checking all these things, because moisture behavior and thermal behavior is really being affected.
Absolutely. I think that's the key, isn't it? We can't afford to do it cheaply. It's not an option. It has to be done right. And if there are economic vehicles that can assist, it's going to be the only way to do it. So hopefully there'll be more.
If you could get a plan for the whole structure of your house, and then with assistance choose the most energy efficient one that you can afford. That, and like Bart did, leave it so you can finish it, which is not everybody's cup of tea. That's a way of getting there slowly. Takes a lot. I mean, and there's a lot of people in a small house. It's not going to be
Yes.
very popular.
Oh, that's great. No, I think that's it's going to be tough, but it needs to be done. So we've had a few questions from Inderpal, and I thought this one is particularly interesting. Alan, how did you determine the 10-year period for analysing the appropriate insulation, and not for a longer period that may be more appropriately aligned with the building lifespan? So what was the reason behind the 10 years?
Okay, the 10 years probably actually should be 9 years now, if I'm honest, because it's a slightly older slide. This was really looking at climate change and trying to make sure that what we're doing now isn't a sort of carbon blip, because if you're going to spend 10 tons of carbon doing your retrofit to save 10 tons, you need to make sure that we're doing it before it's too late. So that's where the 10 years, or probably maybe now 9 years, comes from. And there's more to that. So yes, the installation will last longer than that. So obviously the shorter the payback, the better. I mean, one of the things that we've found quite interesting more recently, with doing some other analysis on this, was with loft insulation. We've often looked at using the Drytherm, the Frametherm 32 in a loft because it's quite high performing. But if you start looking at the embodied carbon of that compared to, say, the 37, which isn't slightly as good, the embodied carbon of the 37 is much, much lower because it's less dense and other things. So actually, using the cheaper insulation is more carbon effective in terms of the embodied carbon. And if you can use more of it, then that's great. So you end up with a much chunkier thing. So that's something we've found, and we're kind of looking at ways of using those sort of installations that are lighter and also fill all the gaps so that they perform much more accurately because it fills the gaps. And embodied carbon. So I think there's this kind of movement there that I think is quite interesting.
Well, that's great. That does make sense. It is critical. These, as you say, 9 years now to avoid catastrophic climate change.
Yeah.
And I think that's why embodied carbon is becoming much more of an issue, and why retrofit is so important. You know, we can't knock down all our buildings and start again and build them all to passive house, because that would be disastrous.
Yes.
Although it would keep us all busy, it would create such a huge carbon emissions now when it's critical that we reduce. It would destroy our goals. There's another one. This one is for Margaret, and it says the largest challenge with retrofitting is that a private client is typically constrained by cost. And how can a retrofit coordinator sell their value beyond these financial restrictions and not undermine the architect, who may be competent but not necessarily past 2035? I think this is it's a really tricky question, and I guess it's how the retrofit coordinator will work with a designer or an architect.
Yes, well, as I said, some of the provisions of the retrofit coordinator role are assuming that someone who's going to become a retrofit coordinator comes with a background in building or design of some sort, and many of these will be architects. So you might be looking for an architect who is also a retrofit coordinator. That's one thing. It's still we were discussing this earlier, the scale of fees envisaged for retrofit coordinators is not necessarily that high. And I wanted to add to our discussion earlier with the panelists that it was mentioned at the Retrofit Academy that a retrofit coordinator might be doing 4 to 6 of these simultaneously at a certain risk level. And if they were just signing off installations, they might be doing 15 or so simultaneously. So sometimes you have to get quotes, and both in terms of what the architects wanted to charge and what the retrofit coordinator was planning to charge. And you know, it depends also on the climate concern of the companies involved. They might be trying to help people do a decent job. That's always possible. So it's really a question of how people pitch their business as designers and as retrofit coordinators. And as I say, they may be the same thing, the same person.
I guess it's down to the complexity of the project and the way it's set up. It would be really interesting to see how that pans out.
Yeah.
Yeah, thank you. How do we convince clients? I'm going to turn to Alex as a client. What do we do? What do we, as architects or designers or building professionals, what do we do to convince you that retrofit is worth paying for?
Yeah, so well, I suppose I'm not the one that needs convincing. It's the people with the purse strings.
That's true. Yeah, absolutely.
The funds, and it's tricky. I mean, it's sort of going hand in hand in a way. Some of the people who give funding for buildings are beginning to sort of make much more stringent sort of demands on this kind of thing. Others, you know, just sort of it's wade through. So I think that the life cycle is the absolute key, and at least the university at high level, the university's governing council have said, look, life cycle needs to inform all decision making. Easy said, actually embedding it in the process is the question. So the process that we've been sort of looking at is not the 10 years but 30 years, which does take us neatly to 2050, and very much focusing on, you know, do you retrofit or do you build new, you know, and hopefully that way of looking at things will encourage retrofit much more strongly rather than sort of just move out and move to a new building. So yeah, the convincing it's a tough one. I think there's been a bit of modelling about what this will cost long term to get to zero carbon. It seems to be in line with what the UK and the world is sort of when they model it on those sorts of scales are, and it's kind of the 1.5% of your kind of economic turnover kind of thing. So it's not, you know, it's not beyond the reach of anyone really. It's a matter of will and prioritization, and just talking about it, using, you know, actually giving robust figures and
I was going to say, I think it's really important that architects think of ourselves as researchers, and that most of the things that we're doing, we're checking what's new, what's been done. And this is where even just Open Eco Homes, seeing how someone else has done it, even if it's not exactly right for you or it's not panned out exactly where they thought, is a hugely important thing. And case studies, I mean, this data warehouse, I don't know how it's going to work out. The low energy buildings database is kind of, you know, very little used, it seems to me, but the potential is there for a job to be analyzed in some detail. These people went ahead and they did it. They had to pay so much, but the cost of windows or whatever has come down now. The cost of PV has come down. The more people do it, the more there's a market. And it is, you know, measure by measure. Some things are still going to be terribly expensive, but others will be less. And I think it's very hard to convince people to be the early adopters. But if you've seen someone else who's gone ahead and nearly got there, and you think, well, actually, these things are cheaper now, that helps. But we have to know, again, homework. You need to know who's already tried, who's done what, and what they used to do it. And that's why I hope I mean, I think the whole of the retrofit coordinator training now is looking at the retrofit homes of the future, looking at the Green Deal, looking at eco, and saying, these things didn't work. We can't do that. We must not do that. And it really is empirical. You go into it, find out what works, and then draw that out and build it up in the next project. And people have got to understand that they need to look at what other people have achieved, and be encouraged, to be, I don't know how to say it, but to be forward-looking, future-proofing. If you think about it now, what worries me is buildings that are being built just to building regs now. I mean, they're going to need to be retrofitted, in the next 10 years? I mean, or 15, I don't know. It just seems very short-sighted, and we've just got to try and make a case for it.
Absolutely. What do you think, Alan? What do you tell your clients?
Yeah, I think it's not about the fuel savings, to be honest. That's a very small part. I often get, what about the payback period? It's not about, it's the comfort, it's the health, it's the durability, it's the maintenance, it's all those things put together that kind of really help. Interesting, I've heard in terms of the industrial buildings that a lot of the financiers now are looking to make sure that they're only investing in sustainable buildings, because they start to think that if I build a building that's not an office block that's not sustainable, that the regulations coming along will make that not usable soon. So I don't want that. Yeah. And so it's purely financial that they're starting to, and so that's going to really, I think, start to drive things. So that will then market other things. So your home will get to a point that I think people won't want it. So you want to insulate it well.
I think it's easy to be cynical about this Green Homes grant, which is a political job sort of thing, but it's creating some momentum. And that's what we want, is people to feel, well, everything's moving a certain way. I don't want to be behind. And each time somebody wants to, improve their workspace because they're working from home, you say, well, you could do this, you could, here's a chance to, and the thing needs to spiral, and it has to, or we'll never get out of this mess.
As long as people don't stop and rely on these handouts, that's my worry a little bit.
Yeah.
People will stop and think, oh, the government's going to pay for it eventually, so I'll wait and get that.
I wish I felt they were doing more training, offering training to builders, making that easy, and really meeting the builders halfway, instead of saying, you got to turn up to this, after work, go and do a course. I mean, they're not going to do it.
Yeah.
Okay, we're coming to 7:30 now, so I think we've got a couple more questions. What should we? So when it comes to the private clients, they are heavily driven by costs and aesthetics former rather than the latter. What easy or tangible information do we have to assist sensible client decisions? I think we've talked a little bit about doing our homework and making it clear for clients, because I guess ultimately, as designers, we're responsible for assisting our clients to make those decisions. I'm not sure if there's if anything we can add to that.
Yeah, I'd just add one small thing. I think it's like being an architect. You're going there, you can do a really good job, you're going to do it properly, compared to maybe going to somebody who's going to do it from the back kitchen isn't trained. So I think it's very much about that value, and as architects we're adding value, and we shouldn't undermine that. And I think often it's the case, and I think it's exactly the same with these retrofits. You need to give that value to the clients in terms of you going that extra mile that's going to be more comfortable, it's going to be healthier, it's all those other things that are going to stop it working. So I think we've got to make sure that we value it. I think there's a real risk that with some of the retrofit stuff that we undervalue the service that we're providing.
Particularly when we look at the elemental cost of insulation. When we bring it down to that, it's then just a number that can be pushed down, rather than thinking about the value, all of those extra elements that you've mentioned, Alan. The benefits to the building, the benefits to the occupants. I'm always reminded by the story of the architect in New York who designs passive houses but never tells his clients that they're passive house, because it's he says that you're getting excellent comfort, excellent air quality, low energy bills, excellent acoustic comfort because of the triple glazing. Never mentions Passive House at all, and all his clients are incredibly pleased with the results because it works, and that applies to retrofits just as much. If you can make a building work as it should, it's going to be brilliant. I think what I'd like to do is just ask for the panelists to give one thing that the listeners can do or to think about in their next project that would assist pushing this agenda forwards.
Well, let me go first.
Yeah, go for it.
I think you need to get to be sort of more of an anorak mentality, so that you should be looking at your fuel bills and seeing how much you're using, and also looking around for different examples and materials, and looking at your EPC. You should know what your EPC is, and you should know what you would need to do to get that up. It's just a crude measurement, the EPC, but it is related to the value of your house, and that's worth doing. If you're willing to put in a new kitchen, you should be willing to do some of these things.
Absolutely, that's a great point. Alex?
Yeah, I think that's a very good point from Margaret. I guess it's having the conversation right at the beginning. These things, it's less of a bolt-on than it used to be, but it's still, the conversations about energy and carbon and so on tend to happen just a little bit too late. You know, if it's right at the beginning of that, fundamentally, how do we do this? Embedded in the way we develop a brief before we even start to think about the design. I think that's the fundamental thing, and yeah, not leaving us with a load of sort of buildings that have essentially become valueless. You know, the decline in value that will be happening to buildings as time goes on will be much steeper than we've been used to historically. So yeah, it's value and long-term value, retaining it. Absolutely.
Thank you very much. That's great. Alan?
I would probably say form factor and shape is one of the biggest things you can do. It's the external surface area that's losing heat. So if you can reduce that down in the ratio to the floor, that makes a huge difference, and it can be cheaper and more efficient. A simple thing like the retrofit of the Victorian Terrace, it had a recessed front door. Moving that front door from the recessed position to the surface saved 7% of the heat energy. That's then also cheaper to retrofit because there's less surface area to do.
And less junctions.
Less junctions, easier. It's just those sort of things can be really cost effective. And if you're designing a new building, the more compact it is, the less money it's going to cost to build, the more efficient it's going to be, the less junctions it's going to have in terms of difficulties with air tightness and cold bridging and all the rest of it. You can still make it look pretty, and you can do different materials and do things with it, but the more compact shape, that it's a real win-win-win thing. So that's kind of be my giveaway.
Absolutely. No, that's great. Okay, well, I'd like to just say thank you to each of the panelists. It's been a really interesting, really informative evening, and some great questions. So it seems strange you don't get the feedback that you do from a live presentation, but I assume that everyone is expressing their thanks to you three. So thank you very much, and I will I think let everyone go on with their evening. So I wish you all the best, and hopefully see you at the next seminar that we'll have in the next few weeks.